Composite repairs are very different from metal repairs because composites don't bend or yield. They're layered materials where fibers and resin work together. Damage may not be visible on the surface, and you can't just hammer or straighten a composite part. Repairs must restore fiber continuity and load paths, not just shape, which makes composite repair more process-controlled, environment-sensitive, and highly dependent on correct procedures and workmanship. Composite damage often includes delamination between layers, matrix cracking in the resin, fiber breakage, crushed core in sandwich structures, and barely visible impact damage from tools or debris. Unlike metals, composites may look fine on the outside while being severely damaged inside, which is why impact zones and load-bearing areas are always treated cautiously during inspection and repair. Most composite repairs involve removing damaged material and rebuilding the structure using carefully shaped plies, usually in the form of scarf or stepped repairs. New fiber layers are laid with the correct orientation, bonded with resin or prepreg, and cured to restore strength and stiffness. The goal is not just to fill the damage, but to recreate the original laminate behavior as closely as possible. Composite repairs are highly sensitive to the environment. Temperature, humidity, and surface cleanliness all matter. Moisture contamination, incorrect temperature, or poor surface preparation can weaken the bond between layers and compromise repair strength. That's why composite repairs are often done in controlled environments using heaters, vacuum bags, and strict handling procedures to ensure reliable results. Curing is the stage where the repair truly becomes structural. Heat and time allow the resin to harden and lock the fibers together. If curing temperature or time is wrong, the repair may look acceptable but perform poorly in service. Quality control checks ensure correct cure cycles, proper vacuum pressure, and accurate ply placement so the repaired area meets strength and durability requirements. After a composite repair, inspections confirm that the repair is sound and free from defects like voids, disbonds, or trapped air. Visual inspection is combined with non-destructive techniques such as ultrasonic testing or tap tests to verify internal quality. These inspections ensure the repair restores load-carrying capability and that the aircraft can safely return to service.